First thing I'm going to introduce is the concept that root 16 over root 9 is what? What's the answer? 4 over 3, because you can break it as root 16 over root 9, which is 4 over 3. You could also write it as 16 to the power of a half divided by 9 to the power of a half. Does that make sense? We're then going to use that knowledge to break this up in what way? What do you think we're going to write it as? X plus 1 to the power of a half and x minus 1 to the power of half. Then we're going to use log rules. ln 9 over 5 can be written as ln n minus ln 5. Using that knowledge, what do you think I'm going to do with my my friend there to the left? What do you think I'm going to break it up into? Yeah. So we're going to break it up into ln x plus 1 to the power of a half, and then take away ln x minus 1 to the power of a half. We good with that? Now there's another rule where we say ln x to the power of 5. Do you know what I can do with that 5? I can bring it to the front and call it 5 ln x. What do you think I'm going to do with my halves? Bring it to the front. Happy days. And we're going to put a half here and a half here. Did any of you do that? Now, have I differentiated yet? Have I done any differentiation? All I've done is log rules. Haven't done any differentiation yet. Now here we go. We're going to differentiate this. You ready? So, what happens when you differentiate a log? 1 over what it is, which is 1 over x plus 1, yeah? Differentiate what it is. What do we get? Just 1. Okay. Now, same thing for this one. It's going to be minus a half. 1 divided by what it is? X minus 1, yeah? Differentiate what it is? Anybody? 1. So, that's all very fancy and all, but what it will turn into is the following. It will turn into, I'm eager to keep the 2 out of it for the time being. See the 2? See the 2x plus 1? Just happy to keep that out for a minute. Huh? Oh, yeah. Sorry, buddy. Actually, I have a way out of that. Happy? Keep reminding me, okay? Now, oh, thanks. Have we killed that? Oh, sorry, minus 1. Now, what's the common denominator that we're missing here? What would make both of them the same denominator? Can you tell me? If I put an x minus 1 top and bottom, and on this one I put a x plus 1 top and bottom. Now look what happens now. They did not give us half enough space to do this, but we'll give it a go. Now here's what I'm going to do. I'm working on this part here, and it's going to be x minus 1 on top. I'm going to multiply out the denominator, just because I'm looking at that. There's no brackets there. That's the difference of 2 squares, isn't it? So it's going to be 2 times x squared minus 1. Going to multiply in the minus. So I'm going to get minus x minus 1 all over 2 into x squared minus 1. The x's cancel, don't they? What's minus 1 minus 1? Minus 2. And minus 2 combined with the 2 underneath? What do you reckon? Minus 2 divided by 2? Just minus 1 on top. And your answer is minus 1 over... now look at this. Look at this, all right? You see that the a squared is minus on this one. Does everybody see that? What happens if I multiply top and bottom by minus 1? What will become of it? 1 over 1 minus x squared. And that almost suits it better. A is 1. That's it. That's a little curveball at the end. We did nothing wrong, but it didn't fit the description of the question. Now, the deal is this thing's a curve. Everybody see this big old graph here? You can represent this on a diagram. And I don't know what it even looks like. Imagine it's a couple of curves, but somewhere there's a tangent to one of them. Is that right? There's a tangent. Now, it claims that this tangent is what? Parallel to the line x plus 3y minus 1. This means we have access to the slope, don't we? So how do you get the slope? Minus x minus 1. Then what do you do then? Divide by 3. And then you use the formula y equals mx plus c. Now what's the slope then? Slope is minus a third. So what we're claiming is that the first derivative equals, what's the first derivative equal? Minus a third. Because the slope is the first derivative, we're looking for coordinates, which means I'm looking for an x and a y. So what did we say it was earlier? Thank you. Keep reminding me. Slope equals to y dx, yeah? And then it's 1 divided by 1 minus 1x squared equals minus a third. Cross multiply and solve. 3 minus 1 plus x squared. 4 equals x squared. It says points, not point. Interesting. I'm claiming that it can be, I'm claiming it's plus or minus 2. One of those answers probably doesn't work. Which answer doesn't work, do you think? It's always the minus, isn't it? Let's find out why. What happens if I put in minus 2 here? Do we? That's perpendicular. I thought it didn't say parallel for a second. Oh, x has to be bigger than 1. So what one does that eliminate? X equals minus 2 is a no-goer. So what does that mean we're looking at? X equals 2. And sub in x equals 2, and what do we get? ln 3, because 2 plus 1 is 3, and 2 take away 1. So it's just ln root 3. So there's our point. 2 and ln root 3. Are we ready? You steady? Yep. All right, guys. Now, how many people think, if I take this part on its own, x e to x plus 1, the top part is a product rule, isn't it? Two different parts. And yet, it sort of resembles a quotient at the same time. Well, look, we're not going to put up with that. We've never done anything like that in our lives. So here's what we're going to do. We're going to hopefully, most of you taught to do this. Hopefully, most of you just highlight the e part like so. And what's x7 divided by x2? Oh, so we should do the same thing. That makes sense. Did any of you do that? X plus 1 take away 2 minus x. So what happens when you combine them? What do we get? 2x take away 1. So now it's y equals x e to the power 2x minus 1. Isn't that a lot more manageable than what we were just looking at a second ago? That's, who tried like a product quotient rule? Now guys, as I said, these type of questions, a lot of curveballs, like, so it's almost these questions I'm giving you, this one's almost a standard higher than what you get in the league, I'd say. But it's good to practice them. Now, what do we think? U is x, so what about the u dx? 1. V, e to 2x minus 1, and then dv dx is Never changes, doesn't it not? And then differentiate the power. 2. All right. Let's do the old product rule. So u times the v dx plus v times the u dx, which is just 2. Now, there's a cheap way of doing this, isn't it? You see the way this one is exactly the same as the last one. See that part is exactly the same as your original. I'll pause. If I was to really spell it out, the y dx is actually y plus 2 e to 2x minus 1. It's back to your original y value. Okay? Now, because we know that, when we differentiate this, what's going to happen when we differentiate it the second time? What can I write down straight away without any work? I can write down the same thing again, can't I? So I can write down x e2x minus 1 plus 2 e2x minus 1. My fault. So guys, my bad. There's a 2 here, yeah? So would you all agree with 2x e to 2x? Yeah. This one? Guys, so let's do this one more time. U is x. The v dx is 2 e to 2x minus 1. So that 2x is perfect. So essentially, and then essentially this is 2 times y, isn't it? Because you're original. So what I sort of wrote down still applies, except I just multiply everything by 2. And there's my shortcut. Right? And then we're going to differentiate this part, and what do I get? Sorry for using green again. What do we get when I differentiate this? The power stays the same, yeah? And what happens when you differentiate it? The power. Differentiate the power, you get 2. 2 times 2. And there we go. We're pretty much done now. We have 2x e to the 2x minus 1 plus 8 e to 2x minus 1. 1 second. Now, this is a point of inflection question, isn't it? Point of inflection question? Agreed? Point of inflection question means the second derivative equals 0, which means we're going to have to do the following. I'm going to remove out e to the 2x minus 1. I'm going to leave out 2x plus 8. Now, let's solve both of these individually, and you'll see one of them probably has a problem with it. So I'm going to write down e to the 2x minus 1 equals 0. Is that possible? Is anything, what's e to the power 1? E. What's e to the power 0? 1. What's e to the power minus 1? 1 over e. It's never, ever, ever 0. If you ln both sides, trying to free up the 2x plus 1, what you're going to see is that ln 0 is undefined. That's not going to work out for us. What does that bring us to now? That brings us to the 2x plus 8. 2x plus 8 equals 0. Therefore, x must be equal to minus 4. Minus 4 is the first coordinate. Go back up to your original function. It says minus 4, doesn't it? So it's going to be minus 4 e to the power minus 4 plus 1, which is e minus 3. And then that's going to be e6. And if you want to know, e minus 3 over e6 is minus 4 e minus 9, or minus 4 over e to the power 9, and you're done. Anybody get that?